To be able to add the lanes to our game, I want to create their own subclass of SEN node, and I will create a new file to do so. So let's right click on our project folder and select new file. It will be a Cocoa Touch class and a subclass of SEN node. The class name will be lane node, and I can then create my file just like in SpriteKit. We have the default import of UIKit right here at the top, which will result in an error since CNode is undeclared. To fix this, simply replace UIKit with SceneKit and the error will disappear. Before we implement the class laneNode itself, I want to write an enumeration called laneType right above it. We will have different types of lanes in our game. And to start, I'll add the cases grass and road, so that we can have grass lanes where our player is safe and road lanes where we have to avoid driving vehicles. I can then jump into my lane node class, which will get one property for now. It will be a constant call type of the newly created lane type. We will then have to create an initializer for our class by writing init and adding one parameter type of type laneType and another parameter width of type CGFloat, which we can use to specify how wide our lane should be. I can then just add the required initializer by selecting the suggested fix from Xcode and then continue implementing our initializer. To start off, I'll have to set a value for our property type, and I will of course just pass the parameter to it by writing self.type and then setting it to type. Since this is the only property of our class, I can then directly call it the superclass initializer, which in this case will just be super.init without any arguments. Our class is completely initialized now, but I do want to add more stuff to my lanes. And to do so, I will below the super.init call create a switch statement, which checks the value of type, so that I can differentiate between my grass and road lanes. I will then have to pass the two cases that we have here. So I'll write case.grass with a break statement. And for the second case, I write .road, which will also get a break statement. I can then delete the default case since we've now added all the cases of our enumeration, making the switch statement exhaustive. Depending on whether we are initiating a grass or a road lane, I want to do slightly different things here. Since parts of those are the same though, I will create a new method right below the initializer, which I will call createLane with the parameters width of type CGFloat, height of type CGFloat, and image of type UIImage. This method will be used to actually create our visible lanes with a certain width, height, and the appropriate image as its texture. For those textures, we will need two new images in our app, which you also have in the resource folder, and I will show you how we can just add them directly to our art.scene assets catalog without dragging them into our project here. So I will bring up the resource folder and then also open the art.scene assets folder in the Finder. If I now just drag the appropriate images, in my case asphalt and grass.png, into my art.scene assets folder and go back into my Xcode project, I can see that they automatically show up in the folder right here. I also don't have to add them specifically to my target apps. If they are inside of the art.scene assets folder, they will automatically be bundled. So let's go back to our lane node class, where I want to actually create the appropriate lanes depending on whether it's a grass or a road lane. For the case grass, in our switch statement, I will define a constant called texture, which will be a UI image with the name art.sceneassets/grass.png. I will wrap this line in a guard statement since this initializer is optional. And if we don't get an image here, I will just add a break statement, since we will need the image to call our createLane method. If we do get the image, we can then just call createLane, and for the width, I will just pass along the parameter from my initializer. Height will be 0.4 for my grass lane, and the image will of course be texture. The width of our lane here specifies how far it stretches to the left and right. Since we are looking straight down with our camera, the height actually specifies how high it is from the ground. And the image will be the texture we are wrapping onto our lane, just like we did it with the floor. For our case road, I want to do something pretty similar by starting with a guard statement where we now try to initialize a constant texture with an UI image named art.sceneassets/asphalt.png. And if that returns nil, I will also add a break statement. If the texture is valid, I will again call createLane with the width. The height this time is going to be 0.05 and the image will be texture again. This way our road lanes will be a little lower, which is also how they are displayed in the original Crossy Road game, and this gives it a more three-dimensional look. Now that we are calling our createLane method from the initializer, it's time to implement it and create the appropriate nodes, which will be added as child nodes to the lane node itself. I will begin by creating a geometry in a constant called laneGeometry, which I will set to a SceneBox instance, meaning a SCN box instance, which is one of the primitive shapes SceneKit provides us. And I will just select the initializer with width, height, length, and chamfer radius. For width and height, I will just pass the parameters from our createLane method. For the length, which will be the length along the z-axis, I will say 1. Since this is as we are looking down with our camera the height of our lane, but this will become much clearer once we actually see the lanes in our application. We don't want any rounded corners, so I will say 0 for the chamfer radius. Now, just like we've configured our floor in our GameViewController class, we will have to set some properties in our laneGeometry, beginning with laneGeometry.firstMaterial.diffuse.contents, which I will set to image, so the image that we get passed in the method, which will either be grass or asphalt. We will once more have to fine-tune our texture slightly and begin by writing laneGeometry.firstMaterial.diffuse.wrapT and set it to repeat, and then do the same for laneGeometry.firstMaterial.diffuse.wraps. Finally, I write laneGeometry.firstMaterial.diffuse.contents.transform, where I'll have to set a scale with a SCN matrix for make scale. This time I will do my scaling a little differently, and for Y and Z just leave it at 1. The X value, however, which in our case defines the width of our node, I want to set in a way that our texture is applied to each 1 by 1 tile of our lane. So the number I will have to pass it here is the width of our lane. I will have to cast this as a float to fix this error. Now, this should conclude the configuration of my laneGeometry with the appropriately wrapped texture. So we can create a node with this geometry by creating a constant called laneNode, which I will set to a SCN node with the geometry lane geometry. And then all I need to do is add this node to my lane node by using add child node and lane node. This concludes our lane node class for now. We will come back to this class later to add some more code. But we will now just test our current implementation to see if we can render the lanes in our game, since this should already be possible with our basic setup here. To test it, I will go back into my game view controller and then add something to my setup scene method. Right at the bottom, after we set the scene for our scene view, I want to add some lanes to my game. To do so, I will use a for loop by writing for underscore in 0 up to smaller than 20, so that we get 20 iterations in each of which we're going to add one lane. Before we add the code for our loop, we will add 3 new properties to our game view controller, which I will add after the camera node property. The first one will be a variable called map node, initialized as a scene node instance. This map node will contain all of our lanes as children later on, so that we've grouped them together. Next is a property called lanes as an array containing lane nodes, which I will initialize as an empty array. This array will contain all of our lane nodes, and why that's important will become clearer later when we actually move through our game. Lastly, I will add a variable called lane count, which I will initialize with 0, and this will be used to position our lanes correctly, since each lane should of course be placed right after the preceding one. Now that I have these properties, I can complete my for loop in the setup scene method and begin by initializing a constant type, which will be laneType.grass for now. I can then create a constant lane, which will be a new lane node instance with the type type, and the width will be 21. The number 21 is just a value that I've come up with, and it seems to be working very well considering that our camera is positioned at 10 above our scene. But feel free to play around with this value if you like. Next, I will have to define the position of my lane by setting lane.position to a SceneVector3 instance for the x and y values. I will just leave them at 0. So x is 0 and y is 0. The coordinate that's interesting to us is z, since I want to position the lanes that I'm looking down on right after one another on the z-axis. I will begin with the z value 5, which should be right at the bottom of our screen. And then I will position any further lanes at lower z positions. And to do so, I will use my lane count property by subtracting the float value of lane count. Therefore, when we add our first node, the lane count is 0, and it will be positioned at the z coordinate 5. We will now increment lane count in a second, so that if we then add our second lane node, it will be 1 and the lane will be positioned at the z coordinate 4. If we now remember that in our lane node class we set the length of our lane nodes to 1, this will position our lanes evenly after one another. So I'll continue by incrementing lane count by 1, and I will also write lanes.append and lane to add this lane to our lanes array. Finally, I can write mapNode.addChildNode lane to add it as a child node to our map. To actually be able to see this, we'll of course have to add the map node as a child of our scene. And we'll do this above our for loop by writing scene.rootNode.addChildNode and mapNode. We don't have to change any properties on our map node, since it's not visible but just the container for all of our lane nodes. Let's run the application, and if everything worked, we should see some grass lanes on our screen positioned evenly after one another. The app started, and I can see my grass lanes. Right at the bottom, I can still see a small piece of our floor, which is fine since we will later on move our camera slightly so that this won't be in our view anymore. We do only have grass lanes at the moment, and it would be nice if we could randomly spawn grass and road lanes. So let's stop the app, and why don't you try and come up with a solution for this and see how we can set this type property in our for loop in a way that it's randomly either grass or road. Ideally, the solution would include some kind of probability parameter so that we can maybe say it's twice as likely that a road lane will spawn. Since our final game should not be too easy, and therefore it would probably be best if the road lanes would spawn more frequently than the grass lanes.